All right, good morning, guys.
Morning.
So we're gonna do the discussion we did on Tuesday real quick. Okay. So I'm gonna use technology today. I found this. Unfortunately, I found this yesterday actually. So this is a good whiteboard tool that you can actually use because I am recording my screen. So I decided, okay, to do the writing things in here as well. Okay. And also, by the way, guys, I'll be posting YouTube videos of recording starting this week. So I already have last week one posted to YouTube. Just need to publish it to you guys. Okay. All right. So this was the problem that we did abstraction real world, right? All right. So pick a real world function and then um, find out the input, find out the output, and that's that. Okay. So I'm going to use, so let me get a box. Okay. I'm gonna put a title as well. So right here. So my verb is like boil pasta. Boil is the verb. Okay. All right. So because if I say cook, it's a two-step process. We first need to boil, right? So I'm gonna only do boil pasta. Okay. Um, okay. So that same goes in. So that's my action, boil. Okay. So the reason this we should do this first in English, guys, because starting week 4, we're gonna learn about how to write software functions, Python functions. Functions are actions. So we use verbs, right? So in English. So it's really great if we can make the connection from English to the Python in that regard. So that's the attempt, this one, first in English, okay? So what are the input? Yeah, boiling pasta.
The ingredients,
Mm-hmm.
the kitchen equipment, or the pot.
I would say that goes into the process, so part of the abstraction. Um,
Input,
yeah,
water.
water, right? Water, pasta itself, like spaghetti or linguine or whatever, right? And then sometimes we put salt as well. Okay, so I have three inputs. Again, these are opinions also, right? So don't like you said, one may think, okay, equipment also input. That's maybe fine as well. Okay, so there's no fine margins here. There are gray lines. Okay, so but this is my thinking of that. Okay, so I'm gonna write it like this, like type. Oops. Right, inputs. Right. One is okay. One is pasta. Dry pasta. I'm gonna write, and then to water, and then 3 salt. Okay. All right. What's the output?
Cook pasta.
Yeah, like boiled pasta. Okay, because cooking pasta it's a two-step process, right? So it's kind of complicated. So I decided, okay, only boiled part I'm gonna do. Okay. All right. So the output is um, boiled pasta, and then we add that meatballs and then olive oil and stuff, right? So onions, right? Those stuff. That's to cook, right? So output basically boiled. Oh, Will faster. Okay, that's it. Okay, so I'm gonna dump this as an image. I think I need to go back. Yeah. All right. PNG. All right. So let's take a. I'm gonna name it as pasta. All right. So go over here and reply, and you can learn as okay. Someone got actual pictures. Okay. So I thought that's actual pasta making or something like that. Okay. So image, upload image, and that's it. All right. So that's my answer. Okay. So need put a. All right. There you go. Okay. So let it reply. Okay. All right. There you go. It's there. Okay. All right. So that's the one. Okay. So we call this black box. Okay. And later on in the class when you write functions, you can actually do the same thing and ask yourself what I am given, that's input, ask yourself, that's your input, and then the action that you want to accomplish is the right function that you know write, and then the output is there. So we call this also in software industry, we call this whole thing is the black box. The engineer knows what's inside there. Anyone else don't actually care. They just want to use it to make get the output. Okay? Right? So so that's why, okay? So figuring out that at the very beginning of the solution of problem is actually a good thing. Right? So that's why. Okay.
So in this case,
Yeah.
so if our boss or our client is
Mhm.
asking us, he goes, this is the information
Mhm.
I'm gonna give you,
Mhm.
and that is
That's
my final product that I
expectation,
want.
yeah.
What's in here, how we do it,
It's
like he was saying, we put it in the pot, and that doesn't matter really, because that's our,
yeah.
that's our domain.
Yeah.
We just kind of,
That's the engineer's responsibility, right? Doing
yeah,
figuring out how to do this. So the client don't care, right? I mean,
correct.
they care if it is too slow, something like that, right? So they may have speed requirement if it's a software piece of program, right? Other than that, they only want the output. Okay.
That's why there's
Even
no,
I have this. Show me how to get that, right? That's it.
that's why there's no pot or steps.
Yeah. So it's inside this process.
It's inside that.
You know, you may be able to boil water inside a microwave and make pasta. Right? Or we can, well, obviously you boil on top of an oven and then make it, right. So you can see that there are variety of ways of doing it, right. Yeah, so that's why it's there. Okay. All right, come on in. All right, so let's move on, guys. So I'm gonna go to SciBook. All right, so this topic is really important. So we're gonna first, I think, so they have given a table over here. Okay, so well, let's begin with this. So I'm gonna start off with the decimal system. Okay, so going back here. All right. So I'd save this one. So I'm gonna reset. All right. So I'm gonna first write the decimal number system, guys. Okay. So numbers in decimal system. Oh, it's not coming. Okay. Numbers in decimal system. So basically, it starts with 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Do we have 10? No, because digits in the system. So we are talking about that. Okay? So it's 0 to 9. Yeah.
Yeah, then we switch to letters.
Yeah, so in 16, right? Yeah. Okay, so basically this is the decimal system we have from 0 to 9. So if you think of a system to remember, it's always 1 less than the base. Base 10 here, so 9 is at the last, 1 less than 10. But if it is 16, it should be 15. Okay, all right. So why 10? Let's go to history. What happened? Like how we got into 10 numbers? Counting. Yeah, 10 fingers, right? So they didn't know this symbols or anything like that, but they used like one, like two, like let's say there are two deer over there, two, like and go and hunt. So they use fingers showing up these numbers. So that's how it came actually. Probably 100,000 years ago, maybe even longer. But then we actually assign a letter, like a symbol. That happened in Middle East, right? 1 to 9. 0 didn't exist even there as well. So 0 originated in India, and then then it got combined, right? So it's 0 to 9. Okay, so that's why we call Indo-Arabic system of numbering, right? Not Roman, right? So all right, so that's base 10. Okay, so now you can have like we already know that computer don't understand this system. Computer understand base 2, right? The binary system. But there are other bases that we are useful as well. Like for example, if you think of binary to represent in binary a big number, big decimal number, you're gonna write huge line of zeros and ones, right? So it's kind of an inconvenience. So that's one of the reasons that we have hex, because hex is even shorter than decimal hex system, right? The symbols. So sometimes if you need these really large numbers to represent things, and let us see that hex color code in HTML programming require big um, binary numbers. So instead of that, we can actually use hex color code. Okay. So in hex, we have um, we have up to 16. So basically, we have 0, 1, and 2, 3, 4, 5, 6, 7, 8, 9. What's next? 10, 10, right? And then 11, 12, 13, 14, and 15. Now, this is a problem. What's the problem here now? There's a problem now, right? It's an obvious problem over here. What is the problem?
Here's the two-digit number.
Yeah, right? So, these are supposed to be single symbols. Digits are single symbols, single symbols, right? So, but instead we have 10 over here. 11, 12, 13, 14, 15. They are in pairs now. That's a problem actually, right? Because they're supposed to be a single symbol. So we used up all the numbers from 0 to 9. So we have to have a convention now to name the rest, right? So the convention is actually use the first 5 letters of the alphabet, English alphabet. So A, B, C, D, E, F. Okay. So instead of this, so I'm gonna delete this. Oh, sorry. right. So I'm gonna write. Okay, so this is going to be the 10 is going to be A. Oh, so this is going to be A and B, C, D, E, and F. Okay, so this is going to be 10. So just to show you the value actually. Okay, so this is 11, 12, 13, 14, and 15. See that? 1 less than 16. Okay, all right. So you got to remember this. So this is the standard digits of hexadecimal system. Okay. All right. So now, so let's start using this one. Okay. So let's leave this one aside first. So come on in. Oh no. Okay. You. Okay. All right. Right. So let's. All right. So how do we convert between, let's say, I want to convert a decimal number to binary. Okay? How do you do that? Have anyone encountered this in high school? Some of you may have, some of you may have not. So how do we convert between number system, in particular from decimal to binary, base 2, base 10 to base 2? Yeah, so we call it repeated division kind of thing, right? So it looks like you know the process, right? So let's learn it, guys. Okay. So imagine I want to convert decimal number. Let's pick a number, a good one. Okay. Let's start with simple, and then we can go after that one. Okay. So I'm going to again dump this one. It's a nice ringtone. Export to X1. All right. So I'm going to reset this. Okay. So here's the process, guys. Okay. So this is really important to learn. Why? Because this may be asked in an interview. Okay. So in particular, like if it is a hardware company like Intel you are interviewing, that's it. Intel has a lot of software engineers, right? Also interns. So they may ask, because Intel CPU does that, right? So, but they want to know how it happened, right? They may ask. All right. So, so here's how. Let's start with 6. Okay. So here's the problem. 6 base 10. I want the answer in base 2. Okay. So I'm gonna get the thinner line. Okay. So she said division, right? So basically, this is what we do. We write 6. Okay. Start dividing by 2. Why 2? Yeah, because we are moving from base 10 to 2. So start dividing by the base. Okay, 2. Okay. So 2. So we get 3, right? So then we write alongside that, we write the remainder, what's left. So when we divide 6 by 2, there's nothing left, right? So 0. Okay. So write 0. Okay. All right. So we're gonna keep doing this. That's why I call this, or we call this, repeated division. Okay. So we're gonna keep dividing by 2. So 2 again, and then it's 1, 2 in 3. What's left is 1. Okay. So we're gonna do this. We're gonna keep dividing this until we reach 0 over here. So we're gonna divide 2 by sorry, 1 by 2 again, and there's nothing in there, so it's 0. What's left is 1. Okay. So now what we're going to do is we're going to read this from top to bottom. Okay. All right. So the answer is basically that's a lousy arrow. I'm gonna undo it. All right. Let's use the arrow. Okay. There you go. All right. So all right. So that's gonna be basically 110. Okay. 110. 2. That's the answer. Okay. Not 011. Okay. Right. So answer is 110 because we write in English from left to right, right? So then we should read it this from bottom to top. Okay. All right. So this is the way any between if you want to convert any to any base from decimal, this is the process. So from decimal to any base. Here it happened to be 2, right? So we divide by 2. If your base is going to be 8, octal that we're going to encounter soon should be 8 over here. If you want this in hex, should be 16 over here. Whatever the base you want, that's the number you want to start dividing by. Okay. So with this process is called repeated division, and this is the technique to mathematically convert between number systems. Okay. All right. So this is from base 10 to 2. Okay. So let's go for so I'm gonna dump this one. To binary. All right. So next one is so let's do the 16 bits hex conversion. Okay. All right. So let's use 30. Okay, 30 in decimal convert to hex. Okay. So 30 in base 10. I want the answer in 16 base 16 hex. Okay. So what should I do? Divide by 16, right? Okay. So 30 by 16. So that's 116. All right, it should be 1 over here, right? Yeah, sorry. Right, there's 116 there, right? So what's left? 14. Right? Right? So when we divide 30 by 16, that's 116 there, right? So yeah. So remainder is 14. So what's left? So remember, we keep going until we reach 0 at the bottom, right? So we're going to do one more time. So 16. So there's nothing in there. So what's left is 1. Now, is the answer is 114? No, right? So then instead of, so this is where it's a little bit tricky now. So once you see 14 over here, it's a complete digit, right? So this should be what? E, right? So this is 1. So we really like this. So the answer is basically 1E. Okay. Base 16. That's the answer. Okay. All right. Anyone have a problem? Questions? I can go one more time, guys. Okay. All right. So yes. Yeah, we can do another example. You can give me a number. 40? Okay, 40. So let's do it over here. So it's 40. So 40 in decimal in 16. Okay. So 40. So there are two. So 16. Okay. So there are two 16. So 32. So what's left is 8, right? So divide one more time. 16, 0, and 2. So it's actually 2 8s, not 28. 2 8 16. Okay. Okay. And you can see that if you get a higher number than this, then you should know that you made a mistake somewhere. Why? Because the base is higher than 10, right? So always the resulting number should be less than this value, like the face value. Okay. This is 30 in 10, so it should be less than in base 16. Okay. So and then you can see over here, right? So 40 got 28 face value, kind of. So uh, in 60. Okay. All right. So this is how we go from decimal to whatever the base. So not just two, any base, and you can go for like odd bases, like like base 59, base 70, base 6. Any base you can convert using this. But in reality, 2, 8, 10, and 16 are the most common ones. Okay. All right. Okay. Anyone else? Questions? All right. Yes.
And where's the drawing app?
Oh, it's yeah. I found out yesterday actually. It's this one, excalidraw.com. So and it's open source. Um, yeah, it's actually you can even share this. Like you can you can embed this. You can share this. There's many things you can do actually. So I found out yesterday. I wish I have known that before, like on Thursday, last Tuesday actually. Okay. So yeah.
Send a message out.
Oh yeah, I can do that. Yes, definitely I'll do that. Yes. Yeah. So and also if you want to, you can. It's an open source project. You can download it and then you can build the whole thing by yourself as well. And then that means it's a and if you do so it still be a browser tab, but it's coming from your local machine, not from internet. Okay. So but that's something complicated, but you can use the tool. They have provided this. All right, so that's that. So let's continue. So okay, so this any other questions? Anyone else? Yes.
Is the class still available on Canvas?
Yes.
Okay.
Yeah. All right. Are you joining today?
Yeah.
Oh, all right. Okay. So, yeah. So I can actually talk to you after the class. Let's talk. Okay?
Thank you, sir.
Yes.
Is it possible to get one more example with a different value?
Yeah. So for the same base.
Yeah.
Okay.
Yeah, 40 with or 8. So
Base 8.
Yeah.
Okay. All right. So let's dump this one. This is I'm gonna say 10 to 16. Okay. And then all right. So this one, you said base 8, right? Okay, 40. Base 10. So I want the number in base 8. Okay. So we're gonna use repeated division by what? By 8, right? Because it's the base. So it's 32, right? Or it's 5, right? Sorry. So 5. So there's nothing left. So we're gonna go one more time. So it's so again 0, So this is actually 5, right? So okay. So basically now we read from like this. So this equals 508. So it's actually 50 base 8. Okay. Okay. All right. Okay. Yes.
So with binary numbers,
Mhm.
do you always have to write the 4 digits? You read from right
That's a
to
very
left?
good question. We're gonna get into
Okay.
that in about 5-10 minutes. Yes, that's a good question. Okay. So pretty much what she asked was that, guys, why this is group of 4. Okay. So we're gonna get into that. Okay. So all right. So this is that. So let me quickly save this one. Um, 10 to 8. All right. And so let's do the other way around now. Okay. So we learned from decimal to whatever the base, okay, including binary, right? So so let's learn how do we do the other way around. Okay. So let's say I have a binary number, and how do we get the respect to decimal number? Okay. So the reverse process. We kind of got a clue on Tuesday, right? So we're gonna kind of repeat. Let's say my number is um, 1, like this one. Okay, so I have this 1 1 0 1. I think this 13. So it's 2. So what I want is base 10. Okay, all right. So okay, so how do we do this? Yeah, so we break it down, right? So remember we broke down the base 10 number the other day? It's the same process here, right? So I'm going to expand this a little bit. So I'm going to write it like 1 1 0 1, but no spaces, just to expand this. So this is 2 to the 0th position, right? This is 2 to the 1 position. This is 2 to the 2 portion, this is 2 to the 3 portion, right? So that means this is 8, and then you can see actually sorry, 8. So this should be a plus over here, right? Plus plus. Okay, so 8 plus 4. So if you want to write it, like I would write like, okay, so yeah, I should have written it like this. Okay, so I'm gonna go back. So this is 1 time, okay, so 1 time 2 to the 3 plus, so this one is coming from, right? So this is the one that coming from, right? This one. So 1 time plus, again 1 time 2 to the 2 plus 0 times, this is 0, right? So it's coming over here, plus again 1 time 2 to the 0, right? So it's basically 1 time 2, basically 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. Okay, so what's the answer? 13, right? 13 10. So this is actually 13 base 10. Okay, if you want to assurance, you can try working the other way around, see if you can get this one, right? You can do so. Yes.
Wait, so for when you're doing hex, for example,
Mhm.
is that I've been having like trouble understanding where you're getting.
We're gonna do a hex as well right now. We're
Okay.
gonna do a hex one too.
Okay.
All right. Yes.
I'm having trouble reading your So the 3210, that's the power, but that's the, like, zeros, tens, 100s.
Yeah, but this is binary, right?
Oh,
So the positions are 2 to the powers.
okay.
We did decimal the other day, right? So powers were in 10, base 10, right? So instead of base 10, so this is basically the twos, zeros position, the ones position, twos position, four position likewise, right? Because these are binary numbers. Don't get mixed up with base 10. So we can do the same for any base. Now the base is going to be the power over here. Okay? So here it's binary, so it's true. Okay. All right. Okay. Am I clear? Anyone? Was I clear to you?
Yeah, now,
Okay.
now I'm reading it.
Okay, okay.
I can see the
Yeah,
two
my
and the
my
three,
my
two
draw
and the
my
three
writing is
same.
not that clear. Sorry. Yeah. Okay. So this is that. So let's okay. So save this one. Say 2 to, oh sorry, yeah, 2 to 10. All right. All right. So let's now do a hexadecimal one. Okay. So you guys can give me a number. Any hex number? 300. Okay. So 300. So this is in hex. I want the decimal number, right? Base 10. Okay. So basically, so you're gonna write it like this: 300. So this is 16 to the 0th position, right? Right. And this is 16 to the 1 position. And then this is 16 to the, so basically it's 0 times 16, right? I should have written like that. Okay, let me get small face and do that. So it's 0 times 16 to the 0 plus 0 times 16 to the 1 plus okay, plus 3 times 16 to the 2. Okay, so 16 to the power 2 is what? 256, right? Times 3. So, so 600 plus 150 plus 18. So 768. Oops, sorry. Is that, am I correct? So this is basically 3 times 256 plus 0 plus 0. Okay. So this is all 0 because we are multiplying by 0, right? I think 768, right?
Yeah.
Okay. So base 10. Okay. Okay. So let's get one more complicated answer, right? So this one is easy because all the numbers were digits, like, numbers. Let's say, like, third, like 5C or something. All right. So our number is this. So 5C 16. What is in decimal? Okay. All right. So 5. So basically, 5 times 16 to the 1 plus C times 16 to the 0 Well, we need to get the value of it, right? What is C? What's the value of C? 12, right? So 11, 12, yeah. So 12 times 16 to the 0. Remember, any number 0th power is 1, right? So 12 there, and then 5 times 16 is 90. So this is 102, right? So 2 base 10. Is that correct? 5 times, yeah, 16 times 5 is 90. And then plus 12. Okay. Make sense? Remember the method, guys. Okay, you can transfer between bases. Like you can get any base number and follow this way. Just need to make sure that this guy needs to be the base power guy, right? And then the power start from 0 and then go all the way up to positive infinity, right? So you're not considering decimal points, but if you want to, it goes to negative powers to the other side, right? So yeah. Okay. So make sure the power is the base. So base is going to be the base over here. Okay. So this is the hard way doing this. I wanted to show you guys because like this is how we do it mathematically, right? So or numerically, right? But if you tabulate this, and that's what her question actually, right? We have this, right? This is the table, so already calculated for us. So all the hex index, hex digits starting from 0 to 15, so it's the corresponding decimal value or the face value. And if you convert them to binary, for example, if you convert this F to binary, you will end up this. So that means the corresponding binary value must have 4 bits. Okay? Even though it is just 0, you cannot write x0 with just 1 0 because it requires 4 zeros. Okay? So that way, you can group them in 4 bits because one 4-bit 4-bit combination of binary value is a single hex digit, right? So that means you start grouping them from right to the left, then you can group into 4 groups, and likewise next 4 is next 4, and then this 4 this is 7, right? 0 1 1 1 is 7. So that from the table, so you put 7 there and take next 4. And then it's 1 1 0 0, so it's like to take that C. That's it. This is C7 in hex. So this is the easiest way. So you need to have access to that table. But probably won't be a interview question, right? So they may ask, okay, show me how to get it, right? Then you have to do the math. Okay. So this can go either the other way as well, right? So let's say you are given C7, you are being asked to get the respective binary number, right? So you go to the table again, right from right to left. Okay. So group them from right to left and write the corresponding binary value from right to left. Okay. All right. And if you don't have enough zeros in front, you can put the required number of zeros to the front. Okay. Let's say you are given this number to convert, right? So then you put one more 0 over here, so that becomes this, right? So it's 4 7, right? So something like that, right? So it's like you can remember, right? So the 0 in front of any number is neglected, right? That's why. Okay. All right. Other questions? Yes.
So that number C7 in hex
Yeah.
Those two pairs of fours for binary.
Yeah, they're binary, yes.
So that would be like the 7 for, if you were going base 10, it would be 7.
Yeah, you can convert that, yeah. It's
You add it though, right?
yeah, so basically I say like there's the same way you can actually put 7 here and then 11 here, and I think that you have add them. That's actually good question to check actually. So did you guys get her point actually? She's saying okay, so can we use the same for converting into decimal?
I mean, you have to treat the first binary number as the 10 to the 0 spot, and then the second, the one to the left,
And then multiply and sum, right?
10 to the 1, right?
Yeah. All right. So this is basically 7. So it's 7. So it's also decimal from 7, right?
12 to the 10 to the 1 is 120.
Yeah. So I think you're right. So basically this is 12 and 12 times 10 to the 1 plus 1 times 7. Right. So that's the answer. Yeah. So that has a math, right? So this has a direct. You don't need to do math between this conversion, but for convert it to decimal, you need to do that math that we did it earlier. Okay. All right. Okay. So that's so we learn both ways of doing it, right, in mathematically. But how do we convert? Let's say again mathematically. Um, let's say hex to binary or binary to hex. How do we do that? This should be a straightforward answer now. Yes.
Just say, wait, what am I converting?
So hex to binary or binary to hex.
And wait, what's the binary?
How do we do that? So what will be the process?
Go to,
Yep.
I've always just gone to decimal and then back to.
Yeah, it's a two-step process now. So you first convert to decimal. From decimal, you can do the other way and then go to binary. But it's a two-step process. We learn both ways separately, right? So now convert directly from hex to binary or binary to hex. It's a two-step process. You first convert to decimal value corresponding, and then from decimal value you can convert either binary or to the hex. All right. Okay. All right, but you guys will be doing this today in the class, okay, towards the end. All right. So let's answer some of these questions. Let's say this one, number 5. So we start from here, group 4, right? This is 5, right? So this will be the answer. Then this is A, right? This is A. If you want to make sure, you can actually check it, right? So this is A, right? See that? So that group is A. So this group is 5, so it's 5A actually, okay? Oh, so the other one, A5, sorry. All right. So because this is 5, the first one is 5, and the next one is A, okay? All right, let's go this one as well. So this is what? That is F, right? So it should be this one then. All right. See that Cyborg has a, I mean, you can logically then guess the answer. You don't have to do the whole thing, right? So I wish Cyborg has given you like 5 choices over here so that you guys have something to work out a little bit more, right? But they are really nice people. All right. Because I didn't have to convert all of it, right? I found out it's the F. What is the answer then, right? All right. So this one, let's do number 4. What should be the answer? Well, this is base 16, right? So we are converting to binary.
binary.
So 7,
So that's gonna be 1, 1, 1, 1, 1,
1, 0, 1, 1, 1, 1, right? So if you're not sure, here's the table. Here's 7, 0, 1, 1, 1, right?
Oh, sorry, I was looking the other way.
All right. So I'm gonna get more space over here. So I'm gonna write 0, 1, 1, 1, and then we're gonna go over here, right? See another 7. So 0, 1, 1, 1, and you're gonna go over here again. Why we are going to the front again always? Because we are starting from the back, right? Coming this way, right? 0, 7, and we have a 0 here, right? What we should have here is 4 zeros, right? Not just one single one. Oh. All right, see that? 0 is 4 zeros, right? The group is 4. So we're gonna write 4 zeros twice, right? 0, 0, 0, one more,
One more.
and one again, one more, 4 more zeros, right? 0, 0, 0, 0. Okay, and then we have F, right? That is
1, 1, 1.
1, 1, 1, 1, 1. Oh, one more.
One
Okay,
too many.
yeah.
And
So
again.
then again, 1, 1, 1, 1. Okay, so there you go. Okay, so remembering that table is really easy actually. So you don't have to do math. But if it's going to be a like interview kind of question, they may ask, okay, show us how it comes. Okay. All right. So and then this is the usage of hex. So color code in HTML is actually given in hexadecimal numbers. 6 digits, sorry, 7 digit hexadecimal, sorry, 6 digit hexadecimal numbers. Okay, and you can render each of these values. You can say other values like like C. Try those out, and then you'll see a different color, right? So yeah, okay, and like like 4 here, right? So you'll see a different color, like a gray. It's a gray, another gray level. Okay, all right. So let's finish it up, guys. Okay, I'm gonna. No, we will finish it up after the break. So be here around 11:10. Okay. By the way, did any of you guys lose an iPad? No, right? Okay.
Okay.
I wanted to make sure because.
Because when I'm typing it-
Hi.
For the example that you did that was drawn, I got 92.
Oh, which example? Yeah, I think I got 92 too.
The one in the XC, the one you drew.
Show me yours and let me check. Maybe I may be wrong. Oh, you're right actually. Yeah, so this is it's not 90, right? It's 80. Oh, okay, yeah, that's my mistake. I'll correct that. You're right. So I made a calculation. So it's not 90, 5 times 8. Yeah, so it's 80.
Yeah.
90. Right. Thank you. I'll correct that.
So you didn't do it the way he was.
I'm not feeling the best. I think I could go home.
Yeah, that's fine. Yeah, fine.
I already finished. I already finished this chapter,
Mm-hmm.
and then a little bit into the next one.
Oh, okay.
So I should be good. The only thing I really had questions on were just like converting from hex to binary.
Okay.
But I think
Okay,
you
now you
covered.
know,
I
right?
think you
Yeah.
covered. You
Yep.
covered my questions. I guess my only question is that when you're going from sorry, I'm sick, but for one of them you added like a plus, and I'm assuming it was because of the exponent.
Yeah, so that's how because you need to sum up, right? So
Correct.
each component, right?
Yep.
So that especially in converting to decimal, you have to do that.
Okay, and then my second question was why wouldn't we do it when we're doing hex to binary or hexadecimal? Why wouldn't we add the exponent for those?
So that requires division, right?
Mhm.
So sorry, hex to decimal. So we did that, right? We did the summation. Decimal to hex, we did the division way, right?
Uh-huh.
But then we didn't need to do that kind of thing because again, the residual or the remainder part is going to be the component of the number, right?
Okay.
So we call it repeated division. So
Yeah.
that didn't require summing up. It just you can write them in and then you can actually you can see that how it comes actually from once you convert to the let's say to the binary or to hex of
Yeah.
decimal. So the underlying theory is still the summation, right? So to the base to the power whatever the position, right? And then they sum up, right? So, but one mechanism to convert from decimal to hex or decimal to binary is by repeatedly dividing from the base. And then if you read the
Until it gets
residuals
to
from
the-
bottom
yeah.
to top, you get the number.
Okay, yeah. I kind of understand. Call me at office hours.
All right. All right. Yes.
So what I'm trying to do this.
Okay. Okay. Yeah, from power 16 to the power 0 plus 16 to the power 1 likewise, right? So this one, we don't do that after the video, by the way. So basically, can I write? Basically, you have 26, right? This is the 0 portion, this is the 1 portion. Basically, divide it 2 times 16 to the power plus 6 times this number times 6 to the power 0. So this should be the answer. Excuse me, I'm getting there's a frog in my mouth. Okay.
Is it okay for the hexadecimal?
Mhm.
I don't do repetitive division. I just do like normal division. Is that okay?
That's
for
fine.
my calculation?
That's fine. Yeah.
Okay.
It's a repeat. It's called the repeated division because you keep on dividing until you reach 0 by the same base. That's
Yeah.
why. Yeah. But it's a division. Yeah. So, Kari? Yeah, then you sum up, right? So this is 1. So this is 6 plus 2 times over 6 is 32. Plus 6. So, yeah. That's it. That's the answer. Yeah, so it's been the 0 and 1. Yeah.
I don't have my answer. So let's say we had like two items. Like weight. We would do
No. This is it. So this is okay. These are the positions. You number the position from right to left. This is position 1, 2. So this is 2 times 16 to the 2 plus 1 time. This one is always this number goes here, right? 1 times 16 to the 1 plus 0 times.
so if we had 1,000.
Yeah. Mhm. That's the pattern. Okay.
Oh.
New York, Ithaca? New York, Ithaca, or
No,
oh, here, Ithaca. Okay.
Mexico.
I just had transferred
Oh, okay.
to the, so now it was working and stuff.
Guys, I think everyone is here, right? Yeah. All right, guys. I made a calculation error in the one of the example. Okay, she pointed me out that. Okay. So remember, we converted. What was the number? What was the number we converted? It's 5C. Yeah, 5C.
It was not.
It's 82. It was 92,
92,
not 102. Yeah, I made a. So I multiplied incorrectly.
I was
5 times 16 is not 90, it's 80. Okay. So the answer should be 92. Okay. So let me quickly do it actually. So did we save this one? I'm not sure.
Yeah, 5 times 16 is 80.
Yeah.
80 plus 12.
Yeah. So 16 to 10. So so this was the answer, right? 5C. 16 to base 10, right? Yeah. So basically it's 5 times 16 to the 1 plus C, which is 12, right? 12 times 16 to the 0. So basically it's this is, I took this is as 90, right? This should be 80 plus 12. So this equals 92, not 102. Okay, base 10. All right. Thank you. All right. So so let's watch our video, guys. Oh, by the way, guys, I think I forgot to show you guys the agenda today, right? So but this, not just that in agenda, this is important. All right, here, right here. Okay. So you guys should read this correction, okay? Please. It's an announcement. It's something that I said on Tuesday class. Okay. So please read that. Yeah. So let's watch our video today. So it's actually a this one. It's already published. Okay, this is fine. Yeah. So this were not supposed to be published, so somehow it's got accidentally published. So that's fine. Preview. Okay, so we're gonna hello everyone. So this is me actually in COVID era. Okay, so 2021. so I'm going really slow, so I'm gonna speed up. Okay, so 1.5, even 2 works. Okay, that on purpose I slowed down at that time. Okay, so let's watch this one, guys. Could
The
you get
objective
the
of this
light?
video is to understand the significance of the digits of a number. So let's take an example number. I'm going to take 1234.12. So 1234.12. Now each of these numbers we call them digits of a number. And since regular numbers are decimal numbers, they are base 10. So we have digits from 0 to 9. Okay. Now I'm going to spread apart each of these digits. So I'm going to write it like this: 1, 2, 3, 4, and we have 1 and 2. Now I'm strategically going to write this same number as a summation, and you will see why soon. So I'm going to write 1000 plus 200 plus 30 plus 4 plus 0.1 plus 0.02. And if you sum up these numbers, you will get the same number. Okay. We can further write these numbers like this: 1 times 1000 plus 2 times 100 plus 3 times 10 plus 4 times 1 plus 1 times 0.1 plus 2 times 0.01. We can also write each of these numbers into powers of 10. So this 1000 is 10 to the 3. Likewise, 2 times 10 to the 2 plus 3 times 10 to the 1 plus 4 times 10 to the 0, it's 1 actually, plus 1 times 10 to the negative 1 plus 2 times 10 to the negative 2. Now if you take all these positions, this number represent this whole thing, and it is this number, and this number represent this whole thing, and that is this number. Likewise, this 3 represent this whole thing, and it is this number, and this 4 represent this whole thing, and that is this 4, and by 1 represent this whole thing, and it's actually 1 here. Okay, so likewise 2 represent this value, and it is this number. Okay, so each of these numbers represent each digit, and you can see that this 1 has the value the most, 1000, and 2 has the value 200. So we can see that the significance of a digit increases from right to left, and we say this 1 is the most significant digit, this 2 over here is the least significant digit. So there you have it, anatomy of a number.
All right, guys. So we went one level to consider decimal values as well. But knowing that, it's really helpful, and you will see that a lot of interview questions are made of those kind of math around. Okay. All right. Could you get the lights? We're going to continue our SciBook lesson. All right. So let's do some of these, guys. So, all right. Oh, let's answer this one. Number 4. So the octal is basically we had this table, right? So if you want to do the same tabulated thing with octal, all you have to do is group by 3 and then go forward. Okay. See, this is the reason, right? So if you forget about this up to 7, if you forget about the leftmost column of zeros, that's octal. Base 7, base 8, right? So up to 7, 0 to 7. So this is the octal system. So these are the respective binary numbers without the leftmost column of zeros. Okay? So if you want, let's say, to convert this same number to octal, you start from right to left, group by 3. And then, so this is 7, right? And then you go to the rest of the zeros. So this is going to be 0, and then this is 2. So it should be 2, 0, 7, 8. The same number. Okay. So that's what you have to do. So, all right. So we can quickly do that as well. So let's do the same number. Right. So this is 2, I think 10 to this way. So let's write the oops. So let's write the same number that we had over here. So it's actually 1000011, right? So 1 0 0 0 0 1 1 1. So this is in 2, so we need in octal system, so we group by 3. Okay, so this is 7, so this 3 again 0, right? And this, so there's a 0, you can put a 0 over here always, right? So we need that, right? So 0 1 0 is actually 2, right? No, let's see, and we can check it over here from the table. 0 1 0 is actually 2. Okay, so we're gonna go here and write 2 over here. So this one, there's a hypothetical 0 over here, so this group going to be 2, so 2 0 7 8. Okay, so group by 3. Yes.
So for the octo
Mhm.
system,
Mhm.
the values for 0 to it's the same values for 0 to 7 as X.
Yeah, right. So make sure though, don't group by 4, just because the maximum digit in octal system is 7, and that's in 1 1 1 1, right? So that's the last one. So you need to group by that amount. Okay. All right. Yes.
If the value is 5 numbers, would you still add 2 zeros or would you not add any?
What do you mean five digits? Like this, like right here, like this much.
Yeah.
Yeah. So you write here, right? You can add one more 0, but it's actually what? It's just 5, right? Yeah. Right. Oh, sorry, it's just 7. So for that one, but if you take an example, so for example, you said 5 digits, right? So let's say 1 0 1 1 1 1. Okay, so there's 7 here, right? So we're gonna add one more 0 to the front. So this is 2, right? So 27 and 8. All right. So you can use the same table for that as well. So let's go and then do some of these. So let's do. So we did that. So hexadecimal is 10 in hex. Sorry, decimal. Sorry. So FFF is like, F is 15, 15, 15, right? So is that or something else? This one, number 3. What's the answer? 49. This one, right? This one, okay. So remember, you cannot put them together and write like that, right? So you have to do this math. Remember we talk about that, right? So you have to do that math to get the answer. Okay. So not this. So from converting this to decimal, it requires some math. But here you can use this table directly to convert between binary and hex. Right. So that's simply arrangement. Okay. All right. All right. So we did this one, guys. So let's do this one real quick. Okay, 38. Convert from hex to decimal. 38. What should be the answer? So 3 times 16 to the 1 plus 8 times 16 to the 0. Right? So 48 plus 8, right? 56. So this is the math. Okay. So likewise, okay. So we have to do that. So we did this one, guys. Okay. The other day, so we covered abstraction. So I'm gonna go to the machine language. All right. So in the CPU levels, basically inside the computer, everything you know that it's actually in zeros and ones, right? So that's why we call it the machine language. Okay. So that's pretty much what the computer understands. So and then you can see that we are adding these two numbers. So let's actually start this one. So first we use the keyboard to enter these numbers, right? So let's play the animation. Okay. So and then we're gonna store them into the memory, right? It's now showing, yeah. Okay. So we're getting input into M101. So that's M, basically the memory. 101 is the address. Think of this as the house number, right? That also in binary, right? So the address also, this is the address, that also in binary. Okay. So, and this is the memory cell, so it can store the value we enter, right? So it is 2, right? So we are inputting. So C2, that's the input. So we are storing it there, and then the next one, so we are storing it in M1110. Okay. All right. So and now we are summing up. Okay. So and you can read the whole process over here. So adding is the instruction is 1 actually add. Okay. So basically that's why it start off with 1. Okay. All right. And then the yeah, and then basically the next step. So let's play that. So the output, right? So the output instruction start with 1010. So that's what we have over here. Okay. And then basically in the end it's stop, right? So we're gonna go into that actually. Okay. So so in the step 7, right, starting at memory this location, so this instruction copies what the type at keyboard, right, in this case 2, and then it's in binary this location, right, and then basically the last step is the output, right? So it's kind of a very simplified breakdown of what's actually happening inside the CPU. Okay, so the last step basically shows you everything, the summation happens. Okay. Yes.
And just for clarification, the memory address box is the RAM?
Yes.
Or
Yes.
that would
Yeah. That's RAM. Yeah. Okay. And you can think of these as like instructions for the CPU. Okay. You know, the process is more complicated than the, for example, there's cache involved, right? So those things are there, but you can get the picture, right? So this is actually happening in zeros and ones, all of it. Okay. So like all the instruction we say like go to this location and get that value and then add this. That also has a binary value, like those all of those. Okay. So you can see that this is really complicated, right? And you cannot really understand that. So that's why we have the um, assembly language. Okay, but before that, let's do this one. So you guys can tell me the answer. First one. What's the answer? Third one. This one. Okay. So basically, we are adding. So let's add right over here, right? And then an M7 and M6. Right. So these two values, and M6 is this. Okay. All right. So let's jump to anyway. So next one,
Last one.
last one. Okay. All right. Third one. Second one. So 0, 1 means the input. Okay. So then this one, right? Okay. So so basically, the way this instruction in the beginning they said one way of they were doing is actually using punch cards. Okay. So and then the other way is like they use actual switches to do that. Okay. All right. We're gonna move on to assembly language. All right. So and then you can see that machine language is really hard to read. So we needed something human readable. So that means computer cannot understand this one directly, right? So you need a translator. That translator is called the assembler. Okay. So we need the assembler, but now it's a little bit human readable. So we write it like this, and an assembler takes care of the translation. Okay. All right. So quickly play this one actually. So it's the assembly language. Okay. So assembler take the and translate it to machine language. Okay. And then CPU takes care of the rest. All right. So it's coming from memory actually. Okay. Stored and then fetch to the CPU. Okay. All right. So I'm gonna go to this one. So it's our last topic in this module, guys. Okay, so and we saw that assembly language also not that fully understandable, right? So we needed even more higher level. So that's the high level language that we use these days: Python, Java, C, C++, all of them. Okay, so that means there's one level of translation need to happen from high level language to the assembly language. We call it actually the compiler or the interpreter. Okay, so all right, so and then that's and there's another example over here. So we are adding x 3 times to get y. Okay, so all right. So there's a so let's do this one. I mean, we can play this one. I think it's help. All right. At M6, M5, M5, right? So first we're gonna do this x plus x, and it's gonna store in M6, right? And that's going to be y, and then y we're gonna add one more x, right? So first M5 going to store the y's value, right? And then that adds it to y again, okay? For x again, okay? So it's a little bit, little bit confusing, right? But try to understand, just for the sake of answering the question down below, okay? All right, so it's outputs y. So if you try to answer this one, what should be the answer over here? It's a bit confusing, right? But you need to review one more time to get the correct answer. Okay? Not M6. If you try to answer M6, it's wrong. M5. Okay? It's because first we do this, right? And that's actually now x. And then we are adding this y to this x again, right? That's why it's actually we are adding y to x in the end. So this should be M5. Okay. So let me I mean, unfortunately they are not explaining correctly as well. If I put the wrong one, let's say M6, and you can see this is wrong, but that's not a good explanation, right? So this should be M5, okay? Explanation is at the top, okay? It's over here. If you read this one, it's actually gonna make sense, but here's also a good explanation over here. All right.
I guess it's because it's replacing. It's
Yeah,
volatile
yeah,
memory.
yeah.
So when you do x equals y plus y,
Yeah,
that's M5.
yeah,
But then you have to add M6.
yeah.
But then it overrides M5.
Yeah, so you're
And
right.
that's what most
That's-
people don't catch on is that
Yep.
M5 is no longer the same
Yeah.
number.
But I mean, they are correctly explaining it over here. It should be the wrong answer though, as well. So second, that's this one, right? So now you are adding again y. So x is M5 and then y is M5. We are adding M5 in the end. All right. So okay, that's it. So we are done with this chapter, guys. So this is a one-off chapter. I will say this. The rest of the modules not going to rely on this one heavily. It's good for the knowledge. Okay. So we're gonna do the group activity now. But any questions before that? There are additional reads, guys, and in here also, I highly recommend reading this stuff. Okay, so you guys should have read this one by now actually. So always there's a extra set of knowledge in these pages, instructional resources. Try to read them as well. Okay. And sometimes they are videos, sometimes they are just pages. And they are free resources. Okay. All right. So let me quickly go over the assignment today. So the discussion assignment is this one. Okay. So you have to pick from the internet. You have to pick hardware, like like a computer or a CPU or let's say an iPhone or something like that, and then you would basically find out the CPU speed, the cache, and RAM and the storage and those stuff, and you have to make a post on that. And as a reply post, you have to find the answer to these questions from the in the reply post. Okay, okay.
Which device is better for-
Yeah. All right, so that's the reply post. So there's an example over here. Okay, so that's the discussion. For the assignment, it's actually so this one. It's actually a quiz. Okay, so but it's actually has 10 points. So if you get the preview, so you need to basically use this W3 school color code and find those answers. Okay, all right, so just answer these 5 questions, and then that's that. So it's not that it should not be that difficult, like the way that the math we had to do. We earlier in the earlier semesters we had that, but we removed that because many didn't do well in that actually because of heavy math involved. But we're gonna do that as a discussion assignment because I will do it again on the other day, right? So next day. Okay. So that's the assignment. So let's do this one right now. Okay. All right. So find your paired person that you worked the other day. Please do this together. Okay, that will be easier, guys. Okay. So we're gonna do basically this. So these are the 10 questions, 10 conversions that you need to do and make a post. That's it. So you can do it on paper and take a picture and submit, or you can use technology as well.
We only have to pick one out of those? Or do it all?
No, all of
Technically,
it.
we already did it.
Yeah,
Okay,
you have to do all of
pull
it.
up.
That's okay.
But again, guys, so I'm gonna do this again with you on next Tuesday. Okay, so don't get too excited on that. Yeah, I can do that. Anyone else need paper? All right.
Hey, what's up? I got, that's my battery to power up.
All right. Yeah. Nice to meet you.
Nice to
All
meet you, Louis.
Nika. Louis. Okay. So you have access. You have access to Canvas, right?
Yes,
Okay. So how was the class today, by the way?
it was good.
Okay,
Yeah,
all right.
It was good.
So so basically, let me go over the things that the modules that. So we finished module 2 today.
Okay.
So you have probably will have to complete these two, right?
Okay.
So, but they are not interdependent. So that means you can right now you can directly access module 2.
Yeah.
Okay.
But I highly recommend in the meantime
What's up? What's your
finish module 1 and 2 as well.
Okay.
Try to go like
Yeah.
catch up, right?
Okay, yeah, for sure.
Yeah.
Okay. All right.
And for the SciBook, do you have the access to SciBook?
I've never heard of it.
So shall we do that together now?
Yeah,
Let's
yeah,
go to
yeah.
your computer and
You
then.
gotta like Word and then just. You mean like, how did I? I actually ended up just typing it in. Cause I thought it looked, yeah, I thought it looked better than. It looked, to me, it looked better like this than a Word doc. The Word docs were good, but like you gotta open up the Word doc. And that's the only reason I did it that way. Yeah, there was literally the only reason I went ahead and, because I was sitting at my computer and it was easy, you just type it in. Versus, see, like the Word doc, you gotta wait for it to download. Like I just clicked on it and I'm waiting for it to download. Now I'm like, okay. You're still waiting. Yeah.
Yeah, I think.
Like Wi-Fi, for this accessing, right?
Yeah,
Pero la
yeah.
realidad es que en el mundo, cuando llegues a la carrera, no vas a
¿Tú crees es más de memorizar?
memoriza las fórmulas, cómo hacer, más o menos. Yo creo que siempre tengo un cartón con
By the way,
las fórmulas
after the
y si se me olvidan,
it's not always okay.
ya, es lo único que uso. A veces, muy raro es la vez que tengo que usarlo, pero si lo tengo, pues ahí lo tengo escrito. Ya, ¿te recuerdas? No sé.
Oh,
En México, íbamos a la papelería y en la papelería nos daban, tenían como formularios, todas las fórmulas, todos y las podías leer con lámina y eso es lo que yo tengo en mi escritorio. Eso lo llegué a, es lo único que
No, me acuerdo de la primaria cuando las primeras tenían todo
es lo mismo.
when did you
Sí, es lo mismo. Cuando llegas al eso lo usamos.
ok, es que sí me recuerdo.
Aquí en la escuela te piden que te lo memorices
Oh,
y quizá en una
okay.
entrevista te pregunten, te hagan
What
preguntas,
happened?
pero,
So, after last week,
pero mientras sepas cómo contestar,
so I actually dropped people who need to.
Ok, ok.
So what I can do
Sí,
is,
porque
don't worry
me
about
empecé a
it.
emocionar mucho
I can
con
reach
diferentes
it.
dije,
But send me your ID and email address and I can reach it. Sorry about that. The reason is we have to
pero luego lo pongo en práctica y digo, oh, no.
Basically, what I know was there were
bueno,
a
yo
couple
tenía un
of
amigo
people I can tell
que
you.
él sabía escribir en hex.
They didn't actually log into Canvas, Canvas Pro.
De su memoria te podías escribir un programa en hex.
So I decided, okay,
Para todavía usamos Waves, él hacía el programa completo en hex
once you get access to
de su
Canvas,
mente y después nos daba un disk y ponías el disk en la computadora y la aplicación funcionaba. Holy shit.
Oye, ¿por qué
Porque si hay gente que se lo sabe, pero no es tan fácil, no. Y este era un
yes.
muchacho que vivía en el basement de la casa de su mamá. Nunca salía, nunca tenía.
claro. Yo tampoco
¿me
sabía.
entiendes?
Oh, porque fue a la escuela usted.
Mi abuela es de México, mi abuelita se enfermó y estaba ya mayor, nos fuimos allá a cuidarla. Entonces, por eso yo viví en Cuernavaca y en Texas.
Este fue el pasaporte.
Sí, soy mitad mitad.
Mestizo. Sí, nunca fui a la prepa. Bueno, yo soy de Yucatán. No parece. Soy de Yucatán. Imagínate que Yucatán es México.
Yo casi nunca fui, solo fui de paseo.
Sí, pero eso fue lo mucho. Cuando yo estaba creciendo, no, solo había una primaria. Ahora ya hay más escuelas. Antes no. Fue muy... Ajá, muy pesado. Yo fui en la escuela de inglés específicamente porque no había escuela. No había.
Me recuerdo, tenían, o sea, estaban las primarias, era una televisión y tenías que ir a ver un instructor que salía por la televisión.
Sí, eso me acuerdo que pasó en la prepa, pero yo no entré a esa prepa, mi mamá me sacó de la...
Oh, you listened me, right? Right. I convinced you, did I convince you? Alright, that's fine.
Pero empecé la escuela, una escuela americana. mañana en línea, pero como estaba trabajando, no pude prestar atención. Pasé con
You were
buenos
incomplete,
grados y
right?
todo, pero
Yeah,
no
then
porque
it's correct.
estudiaba, nomás porque el último año de prepa salió el COVID y ya me dejaron pasar, me dijeron, pues gracias, gracias, y yo, ok. No aprendí nada, nomás estuve ahí trabajando, así que sí recuerdo la verdad.
En el ejército, en la escuela, era un año, la escuela era un año. No, terminamos la escuela. Ya cuando yo era supervisor, llegaban los muchachos de la escuela, acababan.
So I'm trying to learn everyone's name. Elena. That's fine.
So I think you have me there. Yeah, no.
And
Van Dyke.
Dutch.
My grandfather.
Oh, okay.
My grandfather. El 15 lo tiene también ahí.
Okay, anyone didn't lose an iPad, right?
Sí, estoy aquí.
Last time? No.
Básicamente
I didn't.
Es correcto, es porque lo chequé también en internet para ver si está bien y saqué uno, pero son muchos unos, ¿no?
Bueno,
¿Es correcto?
8-1.
Ok.
Bien.
Lo que voy a hacer para el número 3 es nomás, o sea, voy a utilizar este uno y hacerlo en interfaz. Porque se puede hacer eso, el baño de lo puedo usar en vez de o podría usar este.
Como para convertirlo a So, yo
No, that's right,
lo
right?
que hago
Yeah,
es
yeah.
lo cambio de porque este está en décima, right? Y lo quieres cambiar a pero en octagonal no es eso.
No, sí, pero, o sea, lo que yo más fácil me sale es hacer el binary output.
Sí,
Es fácil de dividir las tres, ¿no?
sí,
Es lo que
sí,
pensaba hacer.
sí, la manera que piensas se te hace más fácil. Entonces,
Sí, ok. Y se ve si podía hacer tres.
Yeah, we will do one more time on next Tuesday. Okay.
este es 7, ¿no?
Estoy contándolo.
Así que sí, 1, 1, 1,
Well,
1,
we'll
es
do one more
7.
time.
Entonces 3, 7,
Oh, les conté nomás.
Sí.
Para las 5, o sea, para las 4, yo estuve haciendo de memoria. ¿Es uno F? ¿Es porque el 31.
Porque ahí puedes dividir 16 a 31 es
Yeah.
Okay,
Yeah. Oh, sorry.
ahora estoy con si lo saqué mal.
porque es lo que a mí a veces me confunde es en qué orden va.
Sorry, nine.
El número original es 511.
Porque yo lo que hago es transferir por 16, 31.
Why- why
Y
is
luego
it,
31, multiplicado por 6,
Oh,
Y después es
luego yo lo
email the instruction.
Okay.
Some unfortunately I can tell you don't have regular
y
yet.
luego el 31 y el 16.
I usually say, once they that
Pero no me acuerdo si cuál es la orden.
Es 1F.
Ah, sí.
Si no me equivoco.
yeah, so basically first yeah, you can add voter card and also email because whoever that is that
Okay.
yeah. Yeah. And then one more one. Last one.
Ok.
Yeah. So the remainder
Es
is one
FF.
of the whole
El tres
two was
dígitos.
one, right? And then we have one. So we have basically
Pero esto es usando las
divide
tablas.
by two. One whole two, the other one.
Pero no me enseña
Divide again one by two. There's no whole two in one. Zero.
Yo hago a veces.
What left is one. That's
Capaz porque es 31 por 2. Pues no sé dónde saldría el 2.
of x, the decimal, okay? Sorry, the decimal to x, okay? Yeah.
Quedan 15.
Yeah.
31 dividido por 15.
Yeah, so it's one, right?
So you're just gonna endlessly.
Until you reach zero, yes.
Entonces lo que está diciendo es que
At the bottom, at the bottom.
So 60 goes into 1 0, right?
Yeah.
ahí es donde están los 15.
Ok. Pregunta.
Oh,
¿Qué
you're saying.
significa
When you divide one by
En México nunca decíamos remainder, siempre tenemos que seguir haciendo. Es lo que queda. Es lo que queda. En Estados Unidos siempre hacemos la división.
Alright guys, I think it's time, almost the time, right? So if you are done,
Aquí
you can
hacemos
leave.
las divisiones.
If you have questions, you're gonna take it outside, okay? Because Professor Craig be in the classroom. Yeah. Other than that, we're gonna start chapter 3, module 3 next week, guys. Don't lose that, okay? Don't skip that. That be really important for the rest of the class too, actually. Okay. All right. I'll see you guys on next week. Have a nice weekend, guys. Remember, office hours is Friday 9 to 10. If there's a time change, I'm going to email you.
Pero
Okay.
aquí va a quedar
Put an
31
announcement.
también, ¿verdad? Este es el remainder.
Ok, todavía sobra.
En México nosotros sí,
Alright.
es lo que sobra, es el remainder.
Have a nice weekend. And
En México seguiríamos haciendo lo demás, pero en Estados Unidos no, ahí dicen, ok, ya, ahí, y ese es el remainder.
Are you welcome? See you next week.
Dame tu número porque no vuelvo la semana que viene. Tengo que ir a
Okay.
trabajar a otro
Hi,
lugar.
how's it going?
Good, good. How are you?
Good. Much better.
O si yo doy yo-
These are the two.
Okay.
Yeah, so this one is little, so like probably I think 5-6 people left.
Hasta luego.
Yeah, that's when I realized, oh, I didn't ask that. So it's like close to 1 hour gone. Yeah.
Yeah.
So
Okay. Okay.
and
Thank
then
you.
the iPad. That,
Oh yeah, somebody left that. You said.
some,
Okay.
that I think it was over there.
Okay. You don't think it was one of your students? Did you ask your students?
I asked and then nobody
Okay.
came up. So
Okay.
probably your
Yeah.
class.
All right. Yeah.
So I asked from this class actually.
Good. Okay.
And then there's another one that back
Yeah,
to
the
that
bag,
duffel bag.
yeah.
Yeah, there's someone also from this class, your
Yeah.
class.
Okay.
All right.
All right.
All right.
Yeah. Thank you.
All right. Friday.